Hi everyone, welcome back to my channel. I hope you are doing great. In the last video, we explored the LangChain expansion language, nothing but LCEL, and learned how to create the powerful chain using runnables, parallel execution, and fallback. If you haven't seen that video yet, I will add the link in the description below. It's highly recommended as the foundation for today's topic. Now, in this video, we are dive deep into the LangChain memory, a feature that allows us to store the chat history and manage the conversational context when working with a large language model. Here is what we cover today. What is memory in the LangChain and why it is so important, and different types of memory like buffer memory, window memory, token buffer memory, and summary memory. What is the chat message history and how does it works, and practical code example to implement the memory in your project. By the end of this video, you will understand how to use the LangChain memory to handle the conversational AI effectively. So without wasting any time, let's get started. What comes to your mind when you think that memory in the AI? Let me know in the comments below. So what is the memory in the LangChain? Let's start with the basics. What is memory in the LangChain? Memory refers to the ability to store the information about the past interaction with the LLMs. This is especially useful for the conversational AI application like chatbots or virtual assistant, where maintaining the context across multiple exchanges is crucial. The key points about the memory is memory allows you to save the chat history and fetches them when you need it. Most memory related functionality in the LangChains are still beta. It can be upgraded in the coming days. The chat message functionality is an exceptional. It's largely production ready and integrated with the LCEL. LangChain offers several types of memory to manage the conversational context effectively. This includes conversation buffer memory, window memory, token buffer memory, and summary memory. First, conversation buffer memory stores all the chat messages in the buffer. Passes enter the conversation history into the prompt template. Think of it as a waiting room where all the past interactions are temporarily stored. Next is conversation buffer window memory. Similar to buffer memory but limits to number of exchanges stored. For example, you can set it to remember only the last 3 questions and answers. Next, conversation token buffer memory. Limits the number of tokens stored in the memory instead of an exchange. This is useful for managing a token limit imposed by the LLMs like GPT models. Conversation summary memory stores the summary of the previous chats instead of a raw memory, ideally for long conversation when the summarizing helps to reduce the complexity. Next, what is chat message history? Chat message history provides a conversation method for saving user message and AI response into a list that can be fetched later. Why using the chat message history? It's a production ready and integrates seamlessly with LCEL. It simplifies the storing and retrieving the conversational history. Now let's see the code example of all the memories and conversational chat history. First, we'll import the API key and initialize the LLM. Here, we'll load the .env holds the value of the .env file. Then .env file contains the sensitive information, as you know, that API key. This avoids a hard coded secret key and in your code. And also the os.environment pulls the OpenAI API key from the environment variable. Next, we'll import the OpenAI model. So this loads the chat OpenAI wrapper with the GPT 3.5 turbo model. We'll also use this as an element in the later part. First is conversation buffer memory. Here we are creating the memory instance using conversation buffer memory. Then we are simulating some short conversation using the user asking a question and AI responding the messages. This stores all the messages in the conversation. The use case is when you want the full conversation history has to be stored. Next, buffer memory. The buffer memory keeps only the last some exchanges. Here we define in the k is equal to 3. So it keeps only the last 3 exchanges. Older ones will removed. Why? Because this saves the memory and avoids the passing long history to the LLM. simulating the last 4 conversation. But if you define here, but we define the k is equal to 3, it will store only the last 3 conversation, and remaining last one it will get ignored. Next, conversation token buffer. Next, conversation token buffer memory. Instead of message count, its limits based on the token count. Why token? Because hello is become 1 token and my name is Amarnath is the 4 token. So maximum token here means defining the maximum token is 100. So it stores the message until token exceeds 100. Then it drops the older one. This is useful when using the large language model where the token counts really matters, like GPT. Next, conversation summary memory. Here we are importing conversation summary memory from the memory. We are creating the conversation summary memory with the passing the OpenAI model. This is memory summarize the conversation using the LLM model. To sort the message added, suppose we replicating here, we added the 2 short memory, short conversation, that is a user message and AI message. It will summarize these 2 messages and will store in the conversation memory. This is great for the long chats, storing a summary instead of all the details. Next is ChatMessageHistory. You can think as it gives the memory control over the manually instead of anything. So here we gives the full manual control over the chat history. That creates the history object. Then you will manually add the humans and AI messages. So this is good when you want to manage the history yourself. Now let's connect the prompt plus memory plus LLM model in the real example. Here we are importing prompt template, OpenAI model and conversation buffer memory. Using prompt template, here history is the memory message and input is the user input. So setting the model and the memory, conversation buffer memory. Now we will add some the conversation into the history, nothing but the memory. Then we'll create the chain by combining the past memory plus the new question. Then we'll send to the LLM to process and returns the AI response. To summarize, the buffer memory types will store every conversation. It can be used when you need the full history. Then buffer window will store the k number of message conversation. It can be used when you want a limited history. Then token buffer memory keeps based on the token count and you want to control over the token cost. And summary stores the summary of the conversation. It can be used when you want effective in the long chat. Manual history. You control all the messages from the customer memory to the workflow. Let's summarize what we have learned today. LangChain memory enables to store the chat history for maintaining the conversational context. And different type of memory includes buffer memory, window memory, token buffer memory, and summary memory. Chat message history provides a simple way to save and fetch the chat messages. And combining memory with the LCEL chain allows for dynamically workflow in the conversation AI application. With these all tools, you can now handle the conversational context efficiently in your project. Thank you so much for watching. If you found this video helpful, please give us a thumbs up. It really motivates me to create more context for you. Don't forget to subscribe to my channel and hit the bell icon so you don't miss any episodes in this exciting Gen AI series. Now here is the question for you. Which type of LangChain memory do you think would be the most useful, like buffer memory or a summary memory? Let me know in the comments below. In the next video, we'll see the level 1 application by the code example. Until then, keep exploring and stay updated with all the things in AI. See you in the next video. Bye bye.